that is really developed in Newark. And so, brief introduction. Dr. Gluck's professor of neuroscience and public health at Rutgers Newark, but more importantly, he's the director and founder of the Rutgers Aging and Brain Health Alliance, which is a really exciting community-based participatory research program. Been extremely impressed with what Mark's team has been able to accomplish, particularly with the community to buy in and participation. That's just such a critical aspect in trying to move forward in this area, pathways to healthy aging, and particularly in African Americans. So just really briefly, Mark's a Harvard graduate. We don't hold that against him, but also his Stanford Ph.D. And he's going to be going back home to give this exciting talk shortly as well for that. Really an outstanding neuropsychologist looking at cognitive computational neural basis of learning and memory, has done really beautiful work, translational, a lot of human, but also some very exciting translational work, both in Alzheimer's and Parkinson's disease, active areas on sleep and exercise as far as cognition and aging brain health. So, Mark, thank you. We're really excited to get this big overview, and the floor is all yours.
Thank you. Let me share my screen here, and hopefully, does everybody see that there?
All good.
All good. Okay, so today I want to talk about our work on pathways to healthy aging and our efforts to understand how lifestyle, genetics, and environment interact to promote resilience against Alzheimer's disease in African Americans. Now, you might ask, why focus on African Americans? Well, there are three reasons, because as compared to white Americans, African Americans are twice as likely to get Alzheimer's, less likely to seek and receive treatment for Alzheimer's, and over 50% less likely to participate in biomedical research. So our goals are really threefold to address all three of these disparities. Our targets are to reduce Alzheimer's in the Black community, to increase treatment options early and effectively, and lastly, to expand participation of African Americans in biomedical research. Our program is called Pathways to Healthy Aging in African Americans, a university community collaboration. And it has two parts. The first is an aging and Alzheimer's research program, like you might find at any other sort of neuroscience center or university. But we have a second part, which is our public health component, which is focused very much here locally in Greater Newark. And these two are separate but synergistic. So the aging and Alzheimer's research and our NIH grants provides most of the funding for our public health programs. And in turn, our public health programs build the community awareness and trust that leads to participants in the aging and research. So there are really two parallel programs going on here that are synergistic in the following way. And so I'm going to start by talking about the public health side, how we reach out to the community. We have a 19-year history of community partnerships, the first half of which was just community engagement only, no research. And then in 2015, we began to build on these community programs, develop a program of engagement and research. This means in 2026, which is next year, we're going to be having our 20th anniversary gala, and I can assure you it'll be a fabulous affair you'll want to come join us for. This is our community engagement team, where there are a leadership of three people: Glenda Wright, who oversees our programs with public and subsidized housing; Reverend Wilson, the director of church and other faith-based programs; and Dolores Hammonds, who is our director of participant satisfaction and retention. You'll see and hear from all of them. They're supported by 5 other members of the community, all of whom work on various elements with them in our outreach. And then all of them are supported by students from our lab, graduate students, many of them in public health, some in neuroscience, who work with them. And we often send both a community member and a student out together to sort of balance their skills and expertise. We have a community stakeholders board. It has over 40 churches, 7 mosques, 13 public and subsidized housing sites, and a broad range of other local nonprofits and city and other organizations. So very extensively networked into the city. We have a meeting every other month of our community stakeholders, and it's followed by what we call our brain health salon lunches. We cater this with the best Jewish deli in all of New Jersey, Hobbies, and that's why these are affectionately known as our pastors and pastrami luncheons. For those of you in the area, you're invited to come join us next Friday, February 7th, for our pastrami and pastors luncheon. Most of what we do are smaller programs, lunch and learns at churches and public housing and elsewhere. At these programs, we provide people with information that they can use to reduce the risk for Alzheimer's. 6 steps: exercise regularly, challenge your brain, manage stress, get a good night's sleep, socialize with others, eat a healthy diet. And if you think 6 things are just too much to remember, especially if you have a memory problem, we remind you in many ways, including a magnet that goes on your refrigerator. We also have an expansion of these ideas in a newsletter, a booklet, which we distribute widely that has more information about these 6 steps and how to make them part of their daily life. A long-term partner is the Newark Housing Authority and the City of Newark. There's Mayor Ross Baraka. We've worked with the Housing Authority for many, many years, sponsoring and co-sponsoring events with them. This here's Glenda Wright, who coordinates our relationship with HUD and with the housing, telling you a little bit about what she does and why.
This type of event is so necessary for all of us, because maybe one day we can put Alzheimer's behind us.
Our current participants recruit their friends. A major way in which we engage with the community is through our previous participants. 1/4 of all participants come by word of mouth from other participants. What, you might ask, do they tell their friends and family? And here's what it is.
I give them the background of saying, this is something that's very prevalent in our community. Your mental health is important.
Men are a pain in the ass. Originally, we only had about 7% of our participants were men. Clearly, that's not going to make it when it comes to NIH and looking at sex as a biological variable. I went to one woman early on and I asked her, I said, where are all the men? And she rolled her eyes and looked up and said, they don't need to come here. They know everything already. Last week, a couple of weeks ago, we had an event and a whole table of women, and I asked the women, I said, every time I mention health or education, the men run this way. They run away. And one of the ladies grabbed me by the arm and she said, you tell me which way they're running because I want to go catch one. This has been an ongoing problem. And so we finally realized that the only way to get men to participate was through guile and trickery. That is, to develop special programming focused on men's interests that they would come for, and then we'd sort of hit them with the brain health information. But so what kind of events would that be? Well, one idea came from the fact that I'm a classic car collector myself. That's a Art Deco era French Citroën, and I have many classic car friends. So I reached out to all my classic car friends and asked for their help, and this is what we did.
So we're having a classic car show and men's brain health fair combined for the first time here at Rutgers University, Newark. And the purpose is to reach out to men who traditionally don't come to health education events with local churches with their men's ministry.
We partner with the imams of local mosques. While churches are about 85% women, the mosques are predominantly men. We sponsor an annual Ramadan iftar with the local imams and reach out that way to men. There are 9 fraternity and sororities that are associated with the Black alumni. We've been working particularly with the 5 fraternities. And here we are with the IOTAs and one of our community engagement coordinators, who's a member of one of these sororities herself. And so this way we reach out to more of the men who are associated with these alumni groups. The men's outreach that's particularly meaningful to me is our work on supporting post-incarceration reentry for older men. Every few weeks, there's another older man, Black man who's coming out from the Newark area, from prisons, often 20, 30, 40 or more years. We work with a group called the Returning Citizen Support Group that provides services for persons. It's run by post-incarceration people, and it is reaches out and provides services. With them, we've been providing tech training, Rutgers students who train people coming out of prison about how to use laptops and phones with housing support. And we hired one of them, Jerome Perkins, who I know is here in the audience today. And Jerome has been our liaison to all the programs. With Jerome, we've set up a particular project where we catch people literally on their first day in society. And it's called Meet 'em at the Gate. And when these men show up coming out, we provide them with a nice backpack, a month's worth of toiletries, because many of them go to halfway houses or to homeless shelters, and of course, brain health information. And you see the backpack and one of the recipients coming out of prison. This is Lee Holmes, the man in the white shirt, coming out. This is his first free day after half a century in prison. And keep an eye on him because you'll see him reoccur throughout this talk. So now, since we've begun these directed programs, we've gone from 7% to 25%. Our goal is 35%. There's about a 2-to-1 ratio in the local community, but we've made a lot of progress by multi-pronged outreach to men of the sort that I've described. But for a long-term longitudinal cohort study, which I'll describe a little bit later, it's not just enough to recruit people, you have to retain them. And so for this reason, anytime anyone joins, we call them a VIP. That is a very important participant, and we treat them like a VIP. So once you're part of our study, once you're part of our program, there are a broad range of benefits. You get invited, for example, to book clubs that keep your mind sharp, to exercise classes that are also a wonderful way to prevent dementia. And we run health programs specifically for older adults to help them understand the health system and what they need to know when they go to see their doctors. We send everybody a community brain health newsletter. It's mailed to all participants 3 times a year. It includes lay-level summaries written by professional journalists who we've hired from the local newspapers who take our scientific findings on our community programs and write about them for the general public. And of course, we also distribute this to churches, senior centers, and if anyone in the audience would like to get a copy, we have a mailing list of friends to whom we will send this out as well. Participants are invited to brain health dance parties. Now, I'll say it again, a brain health dance party. You might be scratching your head and saying, well, what the hell is a brain health dance party? Well, this is what it looks like.
And it runs rampant within our community and within our own family.
And you see there Lee Holmes, who I introduced you to before, struts down the Soul Brain dance line with a beautiful lady on his left. And you'll notice that he's not the slightest bit perturbed by that absolutely ridiculous looking fellow on his other side in the red pants and the paisley shirt. Who are these Pathways participants? Who are all the people who joined our study over the years? Let me tell you a little bit about them and their demographics. So the key inclusion criteria are they identify as African American or Black, regardless of where they or their parents were born, 60 or older, speak English fluently, and willing to return every year. And the vast majority are cognitively healthy people, although we do enroll some people now with MCI or mild AD. They live 40% in the city of Newark, about 40% in East Orange, which is another city right on the edge of Newark. We estimate that within the county, there are about 60,000 older African Americans who are potentially eligible for our program. So we've just begun to tap into the local opportunities here. About half of them live in public housing. You see the orange dots there. Those are public housing or Section 8 housing. So half of them are federally subsidized low-income housing. This is a crime map of just the city of Newark. You see Rutgers at University Heights is a fairly crime-free zone, but many of our participants shown in the little flags live in some of the higher crime areas in Newark. Education ranges from 6, that is leaving after 6th grade, up to 20 years. About a third have high school or less, and the median is sort of an associate's degree or some college. So very broad range, but particularly weighted to the lower levels of education. Almost 60% are pre-diabetic or diabetic, very high rates of obesity and hypertension in our cohort. Which brings me to the question of diversity. So we have no checkbox diversity. What do I mean by no checkbox diversity? Everybody checks the same box, African American, Black. But because we have no checkbox diversity, it allows us to focus on heterogeneity of African Americans to try to capture the variations along socioeconomic, educational, religious, life course, and gender so that we really capture a representative sample. And I'll share with you a dirty little insider secret if you promise not to tell anybody. The small number of African Americans recruited into most Alzheimer's centers and clinical trials by pharmaceutical company, maybe they'll get 4 or 5%, and many of them are predominantly higher educated and from upper economic strata, the people who get their health care from a university healthcare system and who trust science and the doctors. And as a result, those other studies, although they may have 4 or 5% African Americans, that cohort is highly unrepresentative and often healthier than the average white participants they recruit. So since 2015, when we began doing research, we've had over 850 older African Americans from the area join our program, and they joined for 2 reasons. The first is to improve their own health and reduce their risk of dementia. They view us in large part as a community public health program dedicated to their health and maintaining health. And second, research, to pay it forward by supporting research on healthy aging. What do we tell other research and clinicians who wish to replicate our recruitment successes? We share widely and openly all of our methods and materials for community engagement recruitment with anyone else who wants to use them or adopt them. Dolores and Glenda and I have traveled to Indianapolis, to Eli Lilly, to Philadelphia, to the Alzheimer's Association, to Minneapolis for the an Alzheimer Research Center, an NIH program. In all cases, talking about our recruitment programs. And the bottom line that we tell in all these cases is the following. We say there is no quick, easy, or cheap way to successfully recruit older African Americans to aging and brain health research. It's taken us 19 years to get where we are now in terms of community engagement. We have at least 16 people, more actually, involved, on a regular basis in this recruitment, and it's taken a significant amount of money from NIH as well as private and corporate donors to be able to have this scale of public health programming that leads to research recruitment. So that brings me to the end of telling you about the public health side. So we recruit all these people into our aging and Alzheimer's research. Why do we do that? What's the purpose of our research? Well, there are 4 key knowledge gaps that motivate our work. First, early detection. How can we detect the earliest, that is the preclinical or asymptomatic phase of Alzheimer's disease, the point at which it's most beneficial? 2, risk and resilience. How do genetics, environment, and modifiable lifestyle factors interact to determine who is most at risk and who is most resilient to Alzheimer's disease? 3, can we develop low-cost, non-pharmacological interventions? What lifestyle changes will benefit which people to build resilience? And lastly, health disparities. How can we assure that all these advantages, 1 through 3, help those most in need, especially African Americans? Let me start by telling you a little bit about some of the contributions we've made to the challenge of early detection. Most of the disease progression is silent. Alzheimer's is probably a 20-year progression. And what we call symptomatic clinical Alzheimer's is probably just the last 5 years when the brain looks like this. By the time someone is diagnosed with Alzheimer's, 80% of the brain damage has already occurred. Much of that can never be reversed. So there's a real clinical need to identify early cognitive decline in Alzheimer's disease years, if not decades, before dementia. So what we really want is here, at the very earliest stage when the brain is still largely intact, to identify people. And that's the challenge that's a major focus of our interests. Our lab's approach to this is very interdisciplinary. We seek to link neuroscience and the neuroscientists in our lab with cognition and neuropsychology, brain and behavior. And the way we do this is through computational or neural network models. Brain theory links the brain and behavior. Now, where do the models come from that we use in our Alzheimer's research? Well, to tell you a little bit about that, I need to turn back the clock and go back not 1, 2, 3, 4, but 5 decades to the 1980s. I arrived at Stanford in 1982 and quickly picked up this beat-up old 1958 Mercedes to tootle around the Bay Area. And I went to Stanford to work with Gordon Bauer, my Ph.D. advisor, who was a major figure in theories of learning. And with Gordon, we developed an approach to understanding human learning, modeling, and experimenting that argued that if you could take the basic principles of animal learning, Pavlovian conditioning, and map them up into a large neural-like network, you could not only understand principles of human learning, but understand some of the biases and heuristics that Kahneman and Tversky and others had described for decision-making. So using animal learning and modeling to link human learning and decision-making. And what we proposed was the Gluck and Bauer model, the configural Q network model, and it suggested that these associations that are formed between a Q and the outcome or the categories to which you categorize it, that the changes in those associations would be similar to animal conditioning, with one particular constraint, that you had to represent the cues not only by the stimulus features such as black and square, but by the unique co-occurrence or configuration of cues, such as something being both black and square, which is why we called it a configural Q network model. And for this, they gave me a PhD at Stanford. I left a few years later in my next car, a 72 International Harvester, drove across country with all my things in it, and got to Newark in 1991, where I was joined by my very first postdoctoral fellow. It was Catherine Myers. And Catherine had joined me, and we began going back to this configural Q network model, and particularly interested in those configural Qs, those co-occurrence detectors, because at that time in the early 90s, there was data coming out from animal studies, animal lesion studies, suggesting that the hippocampus is critical for the sensitive recognition and learning about cue configurations. And from this idea, we developed a model, a neural network model of the hippocampus and associative learning. We published it in 1993 and wrote a book about it in 2001, a book which I'm humiliated to say can now be found for $2.99 on Amazon.com. The key idea here was that how new memories are represented in the hippocampus determines generalization. I'll say that again. Now, how new memories are represented in the hippocampus determines generalization. Now, to understand that key idea, there are two technical terms I need to unpack. What do I mean by represented, and what do I mean by generalization? So let me focus first on what is generalization. Generalization is the transfer of past learning to new situations. So for example, here's Plato. Plato tries broccoli for the first time. It made him sick. He learned to avoid broccoli in the future. What about cauliflower? Cauliflower is similar to broccoli, just not exactly. So Plato has the question, should he eat it or avoid it? Is it similar or different? That's the fundamental challenge of generalization, whether or not and where to transfer past learning to new situations. Animal and human studies have shown that damage to the hippocampus impairs generalization of learning. So there's the hippocampus on the left in red. If we were to obliterate it in Plato's brain, he could still learn that broccoli is sick and learn to avoid broccoli, but he'd never appropriately generalize it to cauliflower. So what do I mean by represented? I've explained generalization. What do I mean by represented? Well, in the brain, representation is often a pattern of activation over neurons or brain regions. So imagine that over a half dozen brain regions, this is the representation, the activity pattern of broccoli. Now, if cauliflower was represented very similarly, with most of the same regions being active, then we would say they have similar representations, and what we learn about broccoli, we would probably transfer to what we believe or expect about cauliflower. On the other hand, if broccoli and cauliflower had completely different representations in the brain, then we had dissimilar representations, and that would minimize generalization. What I know about cauliflower would not be transferred from what I've learned about broccoli. And so this is how we say that how these memories are represented, as shown by two examples here, will determine whether there's enhanced or minimized generalization. So what does this have to do with early detection of Alzheimer's disease, which is why we came here in the first place to talk about? Our later computational models suggested hippocampal subregions. If you go more into the subregions of the hippocampus and the medial temporal lobe, they have different functions. And what we did is we say if we divide the hippocampal region like this, then the brain regions in the lower right-hand corner, CA1, CA3, the subiculum, those we said are associated with the traditional view of the hippocampus as being critical for memory storage, how we store the facts and events. These are the things that we see most salient in someone missing with someone with Alzheimer's, as well as someone like HM, the famous patient with amnesia. In contrast, we argued that the input pathways to this circuit, the entorhinal cortex and the dentate gyrus, are involved in encoding new information, developing the brain representation that's used by the rest of the hippocampus and other brain regions. Now, this is relevant to Alzheimer's because Alzheimer's begins in these input pathways, or at least starts in the medial temporal lobe there, could begin earlier, and makes its way over time from these early pathways later on into the CA1 and CA3. And that's important because current measures of Alzheimer's memory impairments are all looking at measures of memory storage. For those of you familiar with neuropsychology, the mini mental state, the Ravel delayed paragraph recall, all of these, we argued, are capturing what the CA1 and CA3 are doing, which is absolutely affected later in the course of Alzheimer's. But we argued, and this was our key prediction, the early preclinical AD may only affect representation and generalization of learning, not memory storage. So that was the fundamental prediction that we made back in the 1990s about Alzheimer's, presuming that it sort of follows this trajectory anatomically. So our key finding that I'll describe now is that Rutgers generalization tasks identify early cognitive decline in AD years before dementia. That is, we discovered that the earliest cognitive changes are not to memory loss, but rather the loss of the ability to flexibly apply, that is, to generalize learning from one situation to another. So let me give you an example or some sample slides from a task. We have several generalization tasks. One of them we call concurrent discrimination and transfer. So I asked a participant, where's the hidden smiley face? There are two stimuli there. They would choose one. They'd say, I think it's under the left. They'd guess. And sure enough, the smiley face is there. So later on, of course, they'd see other things. Later on, they'd see something in a transfer phase they'd never seen before. They'd see this yellow cross and the red cross. And I asked, where's the hidden smiley face? And if they had generalized the rule that red beats yellow, they would transfer, even though they'd never seen these. So the broader structure of this task is that there are actually 8 discriminations, 4 with a shape rule and color is relevant, 4 with a color rule and shape is irrelevant. And the whole task takes about 15 minutes. And the key idea here is that the rules stay the same from phase 1 to phase 2. What you learn in phase 1 applies to phase 2. It's only the value of the irrelevant dimensions that change. So you have to tune those out from learning in phase 1 so as to apply your rule to phase 2. What we found here, these are patients from NYU who have mild hippocampal, actually they're not patients, they're elderly who have mild hippocampal atrophy, shrinkage. So they're sort of intermediate on the trajectory towards dementia and Alzheimer's. And what we found when we look at errors, so high is bad, is the pink bars are the people with a bit of hippocampal atrophy. They show no significant difference in initial learning on phase 1 errors, but in phase 2, where they're asked to generalize what they've learned in phase 1, we see a big difference. Those with hippocampal atrophy are almost starting over again from scratch. They show no benefit, no transfer. Those without the atrophy, healthier brains, show a lot of transfer. Now, at the same time, we also gave people a delayed paragraph recall, a standard neuropsych off-the-shelf test of memory, and there's no difference. So the message here is really important. What it says is that it's of all 3 of these tasks in these participants, only the phase 2 errors, the generalization. So the message is that it's not learning and it's not memory that captures what you see in the earliest changes in hippocampus in the trajectory of Alzheimer's. It's generalization. So in summary, the Rutgers generalization tasks are innovative cognitive markers for detecting early cognitive decline towards future Alzheimer's disease long before standard neuropsych measures of memory recall are able to detect any deficits. Which leads us to ask what changes in the hippocampus and the medial temporal lobe during early stages of Alzheimer's so as to impair generalization. We do this through fMRI, resting state fMRI. People aren't doing a task, they're just sitting. And we measure something we call dynamic medial temporal lobe connectivity. And the way we compute it is as follows. We do a 10-minute resting state scan, and we divide that 10 minutes into 20 30-second slices. And for each slice, we do a graph theoretic analysis to measure the strength of connections. And by strength of connections, what we're really measuring is the synchrony or the co-occurrence of firing between several key subregions of the medial temporal lobe. And we ask how rigid or dynamic, that is changing, are these graph networks across the 10 minutes, that is across 20 different independently computed 30-second slices. So what do I mean by rigid and dynamic? So here's an example. Flexible dynamic connectivity we describe as healthy. That's where you have these subregions of the medial temporal lobe, and at every slice, they're reconnecting to other subregions, and the groups and the subgroups change throughout the 10 minutes, not because of any task. That's good news. That's a healthy, dynamic temporal lobe. In contrast, a rigid connectivity, which we associate with cognitive decline and risk for AD, the connectivity stays the same. It's rigid. Whatever the associations, whatever the co-occurrences are happening at the beginning of those 10 minutes, it's consistent throughout the whole thing. By analogy, this is similar to thinking about social connectivity at parties. Flexible dynamic connectivity is like a fun cocktail party, where each person there is bouncing around to different conversations, talking to one group of people for a few minutes and then joining another group for another conversation a little bit later. In contrast, rigid dynamic connectivity is like a boring dinner party. It's like the little girl here in this photo who's stuck sitting and talking to the same man all night long. So what you want to be, if you're an extrovert, is at a fun cocktail party. That's the kind of connectivity you want. So in summary, key finding number 2, medial temporal lobe dynamic network connectivity is an innovative new neural network biomarker for AD risk developed by our team at Rutgers, using resting state fMRI to evaluate brain circuits in the medial temporal lobe that are disrupted in early preclinical Alzheimer's disease. I'll come back to show you how we've been using these 2 tools when I talk now about risk and resilience. How do all these factors interact? Why do some people get Alzheimer's disease? Perhaps the most common question one gets asked. Well, there are three reasons. Lifestyle, obesity, diabetes, hypertension, many other things are all associated with changes in your risk. Genetics, some genes increase or decrease your risk. And as I'll discuss later, these genes differ by racial background. They're not the same genes in every racial group. And lastly, environment, your social and physical environment, including stress, noise, and pollution affect risk. So all three interact in complex ways. But you can only modify one of these, that is the lifestyle. And so much of our attention and our focus, both in our public health as well as in our research, has been on these lifestyle factors, understanding them and understanding how they interact with genetics and environment. Let me start by talking about sleep. Here's Dolores, one of our community engagement coordinators, telling the community through radio, this is our old-fashioned social media that we use, radio, a little bit about the importance of sleep.
We're here to teach them what they need to do, and exercising and eating correctly is one of the most important things that you can do. Sleep. We need to get sleep.
So if we look at self-reported sleep quality and we divide people up, what we see is that those who report good or very good quality sleep have the most flexible medial temporal lobe. Those with the poorest sleep have the lowest medial temporal. So we see here a big main effect of self-reported sleep on brain network flexibility, medial temporal flexibility, which leads us to ask, can quality sleep protect brain health in older African Americans who are at high genetic risk for Alzheimer's disease? How good is good sleep and how much benefit can it be, especially in those at highest genetic risk? So let me tell you about ABCA7. ABCA7 is a gene that affects the transport of proteins associated with amyloid, a hallmark pathology of AD, particularly amyloid clearance, as well as impacts a number of other areas of the brain associated with lipids. There are two single nucleotide polymorphisms, that is, variations at different places in the gene. One, the one that you most often hear about when people say ABCA7, we call ABCA780. It's specific to those of African ancestry. The risk allele is rarely found in those of European descent. Those who have this risk allele have double the risk of Alzheimer's as opposed to those who don't have the risk allele. Epidemiologically, ABCA780 is more predictive of Alzheimer's risk in African Americans than APOE. APOE, it turns out, has relatively little predictive value, even when the risk variant is found in African Americans. And we see the same pattern in our data when we look at our neural phenotypes. If we look at variations of APOE4, we see it has very little impact on this medial temporal flexibility. Variations at ABCA780 has a huge impact. So again, ABCA780, not APOE, is what's important genetically, the most important genetically in African Americans. So let me show you some results, and I'm going to unpack them a bit. So here's a direct impact of the risk genotype, the ABCA780 risk genotype, on poorer cognition. So what we see here is red is the high risk, people with the high risk variant. They show more errors on generalization. It's an N of 436, so it's a pretty large sample. In contrast, for 100 people on whom we had brain imaging, those with the high risk variant had lower medial temporal flexibility. So worse cognition, worse flexibility with the high risk variant. But let's focus in on these a bit more. Let's take this cognitive data. I'm going to move it over to the side. And now I'm going to spread it out across 3 subgroups based on their self-reported sleep quality. So we've taken all the data from the people on the left, and we've recalculated it for 3 subgroups. Those who report poor, fair, or good sleep. And what you see in the people who report good sleep, there's no impact of the genetics. So in summary, good quality self-reported sleep eliminates the poor generalization associated with the high-risk genotype. Let me take you back now to the brain imaging data. Move that over to the left there. And again, I will spread that out among 3 subgroups based on self-reported sleep quality. And once again, what you see, if you take the people who have good quality sleep, there's no significant difference in their brain network, their medial temporal flexibility. So finding number 2, good quality self-reported sleep eliminates the lower medial temporal lobe flexibility associated with the ABCA7 high-risk genotype. Pilot data 3, good quality sleep mitigates the decline on RAVEL, one of these memory scores which indicates the beginning of actual dementia over 2 years. So we have a longitudinal study, and what you see is people with the high-risk variant who have good quality sleep show no decline over 2 years in RAVELed as compared to those who are high risk, who have poor sleep, who do show decline. So the importance of taking a nap this afternoon and getting to bed early tonight. So let me summarize for a moment. ABCA780 doubles the risk for AD in older African Americans and is associated with poor cognitive and brain health. Good quality self-reported sleep can eliminate both the cognitive and brain network consequences of this risk, and preliminary data suggests that high quality sleep can offset future cognitive decline towards dementia and memory loss in the risk carriers. Now, in all cases, this is self-reported sleep. It's not objective, and it's of questionable reliability. So what we really want is, in current directions with Bryce Mander at UC Irvine, Rebecca Spencer at UMass, to take the step into quantitative sleep research. And what we're doing is we're using multi-night home EEG sleep monitoring to identify the stages and properties of sleep, including the micro properties of sleep, most predictive of cognitive, neural, and neuropathological measures of AD risk. Sleep is a complex phenomena with many different phases, some of you are familiar with. We're particularly been interested in non-REM sleep, the slow wave that happens in non-REM, and the spindles, the fast spindles that occur on top of it. And there's a lot of past literature suggesting these are disrupted in Alzheimer's and that they're related to memory storage. So in the data I'm about to show you, we used a simple home use EEG with just several electrodes, and it looks like this on a participant. So the first thing is, what does this not correlate with? So it doesn't correlate. So here's spindle density, the fraction of these channels where we detect spindles over during the non-REM sleep. And so if you just look at standard measures of memory, you see no effect. But if you look at generalization, what you see is a phenomenally tight and clear coupling, that the more the density, the higher the density of sleep spindles, the better the generalization that you see. Same story again, if we look at structural imaging, sort of atrophy, which is something which you see in the hippocampus, sort of at a mid-stage in Alzheimer's, no impact of sleep spindle density. But if you look at this medial temporal flexibility from fMRI, what you see is a pretty clear pattern that the more dense that you have these sleep spindles, the more flexible their brain networks. And in some pilot data, higher sleep spindle density is associated with lower plasma p-tau measures of AD pathology. So the higher the density of sleep spindles, the less you have these blood biomarkers of Alzheimer's pathology. So an interim summary, higher proportion of slow wave activity and greater sleep spindle density during non-REM sleep may be associated with reduced risk of Alzheimer's disease. These microarchitecture features of sleep may serve as markers of future Alzheimer's risk, and sleep may thus represent a possible therapeutic target in modulating risk for Alzheimer's, especially in African Americans with the ABCA780 risk variant, whom we've shown can be remediated by high-quality sleep. Some other current directions, we're doing further EEG studies to explore the role of sleep spindles on pathology and symptoms and other measures coming out of the blood plasma especially. And we're now beginning pilot interventional studies with Michelle Chen to see if cognitive behavioral therapy for insomnia, CBTI, can remediate the cognitive and neural deficits associated with this risk allele in African Americans who are suffering from poor sleep. Let me change here and talk about fitness and exercise. We measure fitness from cross-sectionally with a 6-minute walk. How far can participants walk in 6 minutes? This estimates their VO2 max, their maximal oxygen consumption. Again, what doesn't work? If you look at physical fitness against any of the standard measures of cognition, either hippocampal function of memory or digit span of frontal function, you see no effect. You might come away from this graph saying physical fitness doesn't affect cognition in this population. But if we look at generalization, we see, in fact, it does, that the higher the physical fitness, the better this population does at generalization. But what's really here interesting isn't just the fact that generalization is picking up a cognitive benefit, presumably a hippocampal cognitive benefit from physical fitness, but that it doesn't hold for everyone. Now, you remember I said that there were different SNPs of ABCA7. Mostly people talk about 80, which is the one that has a direct risk. But there's another SNP we call ABCA750. It's found in those of European and African descent. It's particularly common in women. And it's only rarely talked about because as a direct risk factor for Alzheimer's, it only increases risk by about 20%. So you don't often see it, but you don't often see it discussed in the literature. But what we see is if we separate our population based on this SNP, what we see is that those with the risk genotype show essentially no benefits, no significant benefits of fitness, but those with the non-risk genotype show a phenomenally strong and tight correlation because we've removed all the people with the risk genotype who weren't showing the correlation. So what does this mean? This means that carriers of the non-risk ABCA7 variant show a strong correlation between physical fitness and generalization, but not to standard neuropsych tests of memory. That those with the risk variant show no significant advantage to being more physically fit. And lastly, that the ABCA750 risk genotype may diminish the neuroprotective value of aerobic fitness. So does this genotype, this ABCA750 genotype, also impact the effects of exercise? Up until now, I've been describing cross-sectional findings across our cohort. What if we intervene within subjects and look at them before and after an extensive regime of exercise? That is, can we help those people with low fitness and low cognition improve on both? Can we make them more fit and in doing so improve their hippocampal function through this measure? Which brings us to personalized, low-cost, non-pharmacological interventions. Which lifestyle changes benefit which people? So our method in this earlier exercise study was we do all the assessments I've talked about. We have a 5-month dance-based cardio aerobic exercise program. It's sort of like Zumba to Motown. It's held twice a week. It was 60 minutes per session. It was held at local churches. And of course, we reassess people after the intervention. So to better understand this intervention, I invite all of you at home in Zoom land on your honor to stand up and do a 10-second cardio dance break like our participants. Here we go. So what did we see after 20 weeks, 5 months? After 20 weeks of aerobic exercise, only carriers of the low-risk genotype showed any cognitive improvements on the generalization. So if we look here at our control participants, these are people who did not participate in this or any other exercise. But if we look at our exercise participants and we look at generalization errors, so low is good, we see that only those who had the low-risk ABCA750 variant showed improvements. Those with the high risk showed no improvements at all. So interim summary. Older sedentary African Americans with the high-risk variant of ABCA750 show less cognitive benefit from a 5-month twice-weekly exercise intervention. It suggests that different people with different genetic variations may require different and personalized prescriptions of exercise to improve cognition and reduce risk for Alzheimer's disease. So how does exercise rewire our brains to improve cognition? Well, if we use the medial temporal network flexibility, what we see is that after the exercise intervention, but not in the control participants, those who exercised after the exercise saw on an individual basis improvements in their flexibility. So we're seeing their brains become more flexible, their hippocampal region more flexible after exercise. Moreover, we link brain changes to cognitive improvement across both intervention and control participants. Control with the blue diamonds, exercise with the circles. We see that the change in generalization from before or after is correlated with the change in flexibility. So what that means is that most of our exercise participants, those with the orange circles, improved on both generalization and on flexibility over 5 months. But what's really scary or of concern is that many of our control participants, those with the blue diamonds who did no exercise, they declined in 5 months, in less than half a year, on both generalization and brain flexibility. So you should take note there. If you don't have a regular exercise program, that should convince you that you don't want to wait 6 months to do it. Summary: exercise promotes medial temporal lobe region flexibility and may prevent increases in synchronicity, that is rigidity, across subregions, protecting against cognitive decline. Where are we going now? We have an NIH R01, a clinical trial with an active comparator group. So we compare people randomly assigned to our cardio dance intervention to a non-aerobic stretching, balance, and strength training program. We ask key questions. Does exercise prevent or reverse the neuropathology of Alzheimer's, measured with plasma markers of tau and amyloid, or are the benefits only compensatory? And how does cardio exercise versus low aerobic training differentially affect brain health? Both have been shown to be beneficial. Can we identify more precisely how they differ? And lastly, what biological pathways mediate the neuroprotective benefits of exercise? And in particular, what is the role of immune function? And we have some pilot data where we looked at T cell senescence. That's part of the adaptive immune system. These T cells, they get ineffective, functional. And what we've shown cross-sectionally, not through exercise, but cross-sectionally, is 15% of the effect through mediation analyses, 15% of the effect of higher aerobic fitness on improved cognition is mediated by lower T cell senescence. And it leaves open the question, how does this apply to exercise? In particular, what about many other immune function markers, particularly the innate immune function? Bottom line, let me try to summarize now, coming towards the end, the last stretch. What do we now know about genetics and lifestyle behaviors that we didn't know before? So here's the big picture. Looks like that. Let me break it down for you step by step. A direct effect of ABCA780 is modulated by lifestyle. So ABCA780 directly affects brain health and Alzheimer's, but it's the degree to which it is moderating that is affected by sleep quality. So a direct effect modified by lifestyle. The other story I told you, the second story, actually, is that there's a direct effect of lifestyle, exercise and fitness is modulated by your genetics. So complex bidirectional relationships between lifestyle and genetics. What we also saw is that it's really important that you're looking at the right measures of brain function. Well, all of our results depend on our looking at this resting state flexibility measure. They all would disappear if all you looked at was structural atrophy. Similarly, our findings all depend on having this very sensitive measure of generalization for subtle changes, early changes in hippocampal function. If instead we had used standard off-the-shelf neuropsych, delayed recall, MMSE digit span, we would have seen no effects. So it's the right tools that are measuring brain and cognition that are critical for understanding these interactions. Where do we go next from here? Let me briefly mention a few other future directions. Can we understand the role of lifetime environmental exposure to toxins, especially pesticides on AD risk? This is a project with the host of this talk, Jason Richardson, and his team at Georgia State. Most of our cohort grew up in the 30s, the 40s, the 50s, and the 60s. And about half of our cohort grew up in the South, most of them in agricultural settings. This was a time in that era when chemical companies assured us and our participants that there was no problem with these pesticides. And in fact, they said that DDT is good for me and you. In the 70s, DDT was banned because it was found to have a number of immediate negative effects. And more recent studies by Jason Richardson and his team have shown that, in fact, DDT exposure, even in childhood, can contribute to increased risk for Alzheimer's and synaptic dysfunction. And that brings us to the next thing we're looking at is we're trying to understand more deeply some of the neural changes in AD using measures of synaptic density, quantitative MRI, as well as using PET imaging to get more detail about the neural changes. We've begun a project of whole genome sequencing with colleagues at the University of Indiana, and particularly asking, how does African ancestry moderate genetic risk, both global ancestry, the kind you would get from 23andMe, I'm 70% African, or local ancestry around APOE and ABCA7. It matters where you got that gene from. If you are of an admixed population, mixed race, mixed background, and APOE is from an African ancestor, it can have a different effect than if it is from a European ancestor, even if you identify as African American. Finally, can proteomic plasma analyses further inform our understanding of how genetic variations affect cognition? Genes are essentially the blueprints for proteins. So by looking at proteins, the tens of thousands of proteins that one can find in the blood, one looks one step down the functional chain of what the genes are doing, and we can get further insights into some of these genetic variations and lifestyle factors by looking at the proteins that are circulating. And lastly, to what extent are the benefits of exercise and sleep due to changes in inflammation and other immune markers? I gave a little hint of that earlier, and that's a project we are looking forward to continuing with our Georgia State colleagues. Another study that's been ongoing is comparing risk factors for dementia in Africans versus African Americans, particularly the Yoruba people in Nigeria, who share a significant amount of genetics with African Americans who are descendants of slaves. And we've been doing sort of a subset of our protocol at the University of Ibadan in the Yoruba people. So I'm almost finished here now, coming to the end. Back to Stanford, my advisor, Gordon Bauer, taught me three things. He taught me many things, but three things in particular about giving talks. He told me always end early, and I think at this point I'm more or less on target for that. He said, give people something vivid and memorable that sticks in their mind, and I hope some of what I've told you, or at least some of the songs and music, will stick in your mind. And lastly, he said, give people something they can take home and tell their parents or their grandparents, some lay-level summary about why this work is important. So it brings me to ask, what should you tell your mother you learned in school today? Well, here's what you can tell your mother. Tell her genetics is not destiny. You can tell her that demographics is not destiny. And nobody captures this principle better than the East Orange Senior Center Silver Steppers, who range in age from 80 to 92. These women are participants in our research study. They are role models in the community of healthy aging, and they are entertainment at some of our community events, as you can see here.
Hey, you! You might notice back in the day. Get on the floor! Yeah, put your hands together, y'all!
So my hope for all of you as we come to the end of this talk is that when you are 92, you are like these ladies up on stage shaking your booty. So let me close with three invitations before I come to the end. Come join us in Israel. In June, we have partnered with Hebrew University and Tel Aviv University with the mission of expanding a collaboration between US and Israeli scientists seeking a cure for Alzheimer's disease. We are looking to support educational exchanges for both US and Israeli students to go back and forth. There's a poster for the conference. All are welcome, and you can learn more at our project at the website below. I run an annual interdisciplinary tutorial workshop on aging and brain health. I know some of you in the audience, such as Jason and others, were at this conference. It's held the first week of January every year. It's designed for people like me who are ignorant and impatient. I don't know anything about 90% of what goes on in the field. I don't understand it. I only have a Ph.D. in psychology. So I want someone to explain it to me in an idiot-proof way with really simple, short words. And I'm really impatient, and I only want to listen to one person for 15 minutes. And so that's what it is. It's about 20 of these little short TED Talk-like tutorials, broadly accessible. The general public is welcome. We get about 20% of the attendees are not scientists, but members of the general public from Aspen, or those who vacation in Aspen. That's a philanthropically place, Aspen. And so through some of our public members who come in, have provided support for our student travel fellowship. So for students who might be interested in attending next year, we'll be putting out a call for fellowship applications. It's located on the mountain. And of course, we would never think of having scientific talks while the chairlifts are running. And so it goes from 4 to 7. It's very small. It's 50 people. We expect it will sell out. And the idea is to keep it small and intimate. So if you have your calendars out now, here's a preliminary poster for 2006. It'll be January 6 to 8, Tuesday to Thursday. The last invitation is to come join us for Giving Brain Science Back to the Community. What is that? That is our annual formal black tie gala at Rutgers Newark. It's held every July in Newark, just prior to the annual Alzheimer's International Conference, wherever that is. All our Pathways participants come, and our community partners come, and they're invited to see updates on what we have learned from them. So if you're in the area or considering in the area, July 22nd will be our next black tie gala. Of course, you'll be expected to dress appropriately. At these meetings, our students like Peyton and Darianne present through posters, which they'll later give at AIC, to the community members some of the science that we've learned over the previous year. The local pastors show out in force, and here they are at our last event. Our lab members come and in their finest to participate and interact with community members. Everybody is there. Lee Holmes, who I introduced you to early on in the red jacket, is there with several other returning citizens with Dolores and I. Our exercise participants show that not only can they do their routines, but they can do them in heels, walking backwards. And a good time is had by all, including yours truly. And that brings me to the end. I've had a good time with all of you. That's about 55 minutes. I want to thank you all. And this was made possible with support from grants from the NIH, from private foundations, from donors. And as a final last request, I'll note we're always looking for new team members. There are about 45 or 50 people in my lab at the moment. And so there's constantly a turnover and a need for post-bac research assistants, PhD students, and postdoctoral fellows. And if you're interested in any of that, please visit my website or give me a call. So that brings me to the end. Okay. So we're going to have a two-part question and answer. The first part is going to be for everyone not at Rutgers and not at Georgia. So for everyone else who joined in, if there are questions, please unmute yourself and ask a question. We'll do that for about 5 minutes or so, 5 or 10 minutes. And then I'm going to ask everyone else not from Rutgers or Georgia to exit out. And we're just going to have a private meeting to talk about some of these collaborative projects. So let me open up to everyone non-Rutgers. And there's Angela. Is that a hand or is that a clap? I can't tell.
It was a clap. Just enjoyed the presentation.
Thank you very much. So do we have any questions? Just unmute yourself and talk New York style. Just interrupt and start speaking. Any questions?
I'll ask a question.
Okay, Jason.
I'm the non-scientist, general public interested observer. This contrasts greatly with the sort of things I saw at the SNOMES workshop. The level of detail, the continued focus that you were able to present for such a long period of time compared to what we saw at the workshop. I am a fan of both. I just want to say that as a comment. But is there any chance that somehow there's a middle ground in the middle that Aspen will work towards, or do I just need to be flexible?
This is a scientific talk about what we've done at our lab. The Aspen is really about going to school again and getting educated by people as teachers. So two very different. Come to both, come visit us. But thank you for coming in.
Thank you.
Any other questions? If this was an undergraduate course, I would call on people, but that doesn't seem appropriate as a speaker here. Anyone else have any questions other than the Georgia and Rutgers teams?
I had a quick question about.
Hi, Karen. You're from California, from USC or UCLA?
No, so I just joined the HABS HD team, and before that, I was with WashU Med in their neurology department. But the question I had was, have you guys compared the MTL resting state measure to any other graph theory metrics, maybe like segregation or anything else? Is that the one that you guys have always focused in on, or have you guys also seen, like, are there comparable or complementary measures?
I think that's a great idea. I know that you're meeting with Sudha and Marai in the next week or so, and I would turn everything over to them. So let me just ask if I think that's a great idea. And if you have any specific ideas, if you can share it with Sudha and Marai, maybe that'll be the next round of stuff, and perhaps some stuff we might do as part of a collaboration with you that we're eager.
Great. I appreciate it. Thank you.
Any other, I see there's a chat. I don't know if that's a question.
I have a question.
Yeah, where's that? Who's?
Adri, I have a question.
Sure.
When you talk about early detection, there are, several factors that contribute to you being able to detect this, or anybody being able to detect it earlier. I'm talking about the Alzheimer's and specifically dementia. My question is this. My question is twofold. One is, what are the early symptoms that perhaps don't even look like dementia or anything that may appear? What are the early symptoms? And the second is, does being able to be present and being aware that where your attention is at every time, so that means being attentive to everything that you do, does it play a part in recognizing if this is just you're not paying attention?
let me just take it there. So in terms of the earliest signs are what we were talking about. I mean, the earliest signs that a family member might know can range from psychiatric, there can be depression, there can be many other symptoms. But the most salient is, of course, memory loss and the ability to forget things that just happened. And in terms of attention, there are attentional changes in dementia. It's not something we focus on, but it certainly would happen, but probably tends to be later. So let me thank you and move on. If there are any other questions, but thank you, Audrey. If there are no other questions, then let me just bring to a close the more public part of this and just ask for the Rutgers and Georgia people to stay on, and we'll talk about some of our collaborative projects moving forward. And to the rest of you, thank you so much for joining us.
Yeah, thanks,
Thank you so
Mark,
much.
for
It
a
was
great
amazing.
presentation.
Amazing presentation.
Thank
you.
Incredibly detailed. Yeah.
Thank you all. Okay.